So in part 6, we're going to look at demonstrating an understanding of the inverses of relations. We've actually seen inverse functions before. So a function is a machine that turns x values into y values. For example, if you have the sine of x, you can get y. So if you know that x is 30 degrees, you can figure out that y is 1/2. The inverse of a function is something that we've been doing with trig functions for years. That's where you figure out what the x is based on the y. And this -1 exponent is the sign that we have an inverse function. So generally speaking, if we have f of x equals y, then the inverse function is the function with a -1 up here that takes our y values and make them x's. This will be able to connect to the reflection we just saw because it's exactly the same as reflecting in the line y equals x. Where we used to have x, we now have y. Where we used to have y, we now have x. This is going to be equivalent to that reflection when we are taking the inverse here. So that is the key. We're also going to be looking at the fact that most functions are not still functions after we've done this to them. So even though they're frequently called inverse functions, they're more properly called inverse relations. Remember, to be a function, you have to pass the vertical line test. Y equals x squared passes. But once we've taken the inverse, it fails, because now it crosses twice. So in order for a relation and its inverse to both be functions, that function will have to pass the vertical line test, and it will have to pass a horizontal line test. So we need these two tests together, because a horizontal line test, once reflected in y equals x, becomes a vertical line test. So if the inverse relation passes the vertical line test, the inverse relation is a function. And we will be able to put tighter and tighter restrictions on it as the time goes on. There are some restrictions we can't do formally that are coming later. That's university level because it does require calculus to prove it rigorously. But if the slope is never 0, it is either always positive or always negative, then the inverse relation and the original will both be functions. That is the criteria that needs to be met. So that is the very, very basic nutshell version of inverse relations.